In this lesson, we're going to extend your knowledge of the elimination method just to work on a little bit harder problems. So this is part 2, when we beef it up a little bit. And we're just going to do a couple problems because the rules are exactly the same. So first we have to make sure they're in like columns, which luckily they are, both in standard form right now. Second, you want to make a pair opposite. So I like to look, is it easier to make the x's opposites or the y's? Well, since 2 goes into 6, it's going to be easier to make the y's opposites. And since I want a pair of 6 and negative 6, what I think I'll want to do is multiply this bottom equation by 3, because that's going to give me a negative 6y, and I'll have a pair of opposites. So I'm going to go ahead and distribute and simplify this. It's negative 15x minus 6y equals negative 42. In the first equation, I'm not going to change it. I'm going to write it exactly as it is. 3x plus 6y equals negative 6. So now I have a pair of opposites. I'm going to add these two equations up. So 3x and negative 15x, that's negative 12x. 6y and negative 6y disappear. Great. That's what I want. And negative 6 and negative 42 is negative 48. So now, again, one simple equation, one variable. I want to divide both sides by negative 12, and I get x equals 4. But wait, I'm not done because I have to figure out what y is. So pick whatever equation you want and take this x equals 4 and plug it in. So I'm going to write 3 times 4 plus 6y equals negative 6 and solve this one for y. So I've got 12 plus 6y is negative 6. I subtract 12 from both sides. I get 6y equals negative 18, and I divide both sides by 6, and I get y equals negative 3. So now I think my ordered pair is 4, negative 3. I'll write that as my solution, and I'm just going to do a quick check. So in the first equation, 3 times 4 plus 6 times negative 3, well, that's 12 plus negative 18, and that's negative 6, which is what I want, because I set it equal to negative 6. And in the second equation, negative 5 times 4 minus 2 times negative 3, I want to know if that's negative 14. So this is negative 20 plus 6, which is negative 14, and it's what I want. So I must have the correct solution. 4, negative 3 is right. Okay, let's do one more. This is the trickiest kind probably that you'll see, when neither the x's or the y's are as a factor of each other. So sometimes, this is kind of annoying, but sometimes you have to multiply both equations to get a pair of opposites if you don't want to deal with fractions. So that's what we're going to do in this case. So you can either choose to make the x's opposites or the y's. I'm going to choose to make the x's opposites. And since 3 and 5 both go into 15, I'm going to try to multiply them by something that makes one of them 15 and the other one negative 15. So I'm just going to kind of arbitrarily choose that I'm going to multiply the top equation by a negative 5, and then I'm going to multiply the bottom equation by a positive 3. Oh, and by the way, if this negative sign in front of the 5 wasn't in your packet, throw it in. Okay, so multiplying the first one to get this set, we have negative 5 times 3x, that's negative 15x. Negative 5 times negative 4y is plus 20y. And then I forgot to write it on this, but I need to multiply this side by negative 5 as well. So 38 times negative 5 is negative 190. Then my second equation, 3 times 5x is 15x. 3 times 7y is 21y. And then negative 5 times 3 is negative 15. So this is good because my x terms are opposite, so they're going to cancel out. When you're trying on your own, if you don't get something to cancel out, think about the multiplier and you might need to change that. So here, that's 0, and then 20y and 21y is 41y equals negative 205. So I have to divide both sides by 41. And I get y equals negative 5. I'm going to take this value that I got for y, and I'm going to plug it in, and I'll choose the second equation in this case. It doesn't really matter. Plug it in right here. So I have 5x plus 7 times negative 5 equals negative 5. So then I'm going to solve this. 5x minus 35 equals negative 5. I'll add 35 to both sides, and I get 5x equals 30. And then when I divide both sides by 5, I get x equals 6. So I think my solution is 6, negative 5. And I've messed this up before, so I want to just check it really quick in the other equation. So 3 times 6 minus 4 times negative 5, I want to check if that's 38. This gives me 18 plus 20, which is 38, so I probably got this equation right, the system of equations.